Welcome to ET282, the microcontrollers course. In this section, we will be looking at the foundations that you need, or the introductory material for this course. We'll be taking a look at particularly how the microcontroller that we're going to be studying, the PIC-18 microcontroller, how it's set up, what its architecture is, how it compares to some other microcontrollers and computers. In this section, we're going to go back and look at some of the things that you should have learned in previous courses, but they're always worth going back and doing a review and building on that material from previous courses. So we're going to take a look at a review of numbering and coding systems, go back and look at a little digital primer on the digital devices that you learned in your previous digital logic design, and then look inside the computer and see how it compares, how microcontrollers compare to computers. In this section, we'll be looking at the typical conversions, number systems, base 2, base 10, base 16, binary, decimal, and hexadecimal, and how we convert back and forth. You've had them before, but it's always good to go back and take a look. We'll look at things like adding and subtracting hex numbers, adding binary numbers, looking at representing any binary number as a 2's complement. Machines typically do not add and subtract the way we're used to in our decimal system. They do things by using a complement system to do the addition, and then they end up throwing away parts of the final answer. Representing alphanumeric strings and things called ASCII. You've probably seen the ASCII coding charts before. And as you relate that to your keyboard, all of your keys on your keyboard are all ASCII coded. And there are all of the special characters can be displayed if you know the ASCII code or the ASCII shortcut. Looking at the logical operations, again, a review of and, or, not, exclusive or, not and, not or. These are all very common logic devices and logic methods that will be needed again as we progress through this course, because some of the problems you'll look at will require you to use these devices, and it makes the programming of the microcontroller a lot easier. Using logic gates then to diagram simple circuits, explaining the difference between a bit, a nibble, a byte, and a word. Again, you've probably seen these, but it's worth going back and reviewing them. Given precise mathematical definitions of the terms kilobyte, megabyte, gigabyte, and terabyte, again, you need to know how to relate those as numbers and as metrics as we proceed through doing the programming in the microcontroller. Describing the purpose of the major components of a computer system. And the idea behind this is looking at what you understand or know of your PC or your Mac or any machine that you happen to be using, and how it relates to a microcontroller. Microcontrollers, computers, and microprocessors are all different animals, and we need to know how to view them and understand what their capabilities and their limitations are. Explaining the difference between reading available memory and reading only memory, your RAM and your ROM, and describing the purpose of each type of bus on the particular circuit board. Describing the role of the central processing unit, the CPU, in a computer system. And then finally listing the major components of the CPU and describing the purpose of each. Again, some of the devices and components in a computer, in your PC, your home computer, some of the components match, some of them do not. So we're going to look at what the differences are. So now what we're going to do is go through each of these sections that I just briefly described for the course and do a review then of numbering and coding systems. So we'll do that in the next video. Thank you.